Hello and welcome. Today, we're going to pull back the curtain on something called PACS. It's this invisible but absolutely essential piece of technology that's running behind the scenes in modern medicine. It's really the digital engine that makes today's radiology even possible. So let's dive in and see how it all works. You've been there, right? You get an X-ray or a CT scan, the machine buzzes and whirs, there's a flash, and then what? Where does that picture of your insides actually go? How does your doctor get to see it just a few seconds later, maybe from an office that's miles away? Well, that's exactly the mystery we're going to solve today. All right, here's our game plan. We're going to start with the basics, what PACS even is. Then we'll look at how it actually works, and we'll meet the person who runs the whole show. After that, we'll get into the secret languages it uses, how it's kept up and running, and finally, why any of this really matters for you and your health. So let's kick things off with that big question. What exactly is this system? I mean, it's completely taken the place of all that old school film you used to see in hospitals. Okay, so PACS stands for Picture Archiving and Communication System. And honestly, the name tells you pretty much everything you need to know. It's the tech that archives or stores all of those medical images, and then it communicates them to the doctors who need to see them instantly. We're talking no more running around with those big film jackets down hallways. Probably the best way to wrap your head around it is like this. PACS is a giant, super secure digital library. Every single scan a hospital takes, every X-ray, MRI, ultrasound, you name it, is like a book that gets instantly cataloged and put on the shelf, ready for any authorized doctor to check it out, anywhere, anytime. So how does this digital library actually function? Let's follow the journey of one of those images right from the moment it's created by the scanner to the second it pops up on a radiologist's screen. The whole thing really boils down to 4 simple steps. First, the image is acquired by a machine. Second, it's sent across a secure network. Third, it's stored in a central archive. And fourth, it's viewed on a special computer. Acquire, send, store, and view. That's the core of it right there. Now, when we say acquire, what are we actually talking about? We're talking about the imaging modalities, which is just the fancy technical term for the machines that create the scans. This is everything from those massive CT and MRI scanners to digital X-ray machines, the wands they use for ultrasounds, and even those tiny little cameras from an endoscopy. They're all sources feeding new books into our digital library. But this incredible system doesn't just run on its own. There's a super important human element, a specific role that sits right at the heart of it all, the PACS administrator. You really can't overstate how complex their job is. See, they're not just an IT person, and they're not just a clinical expert. They have to be both. They're the ones orchestrating this whole symphony, acting as the essential bridge between the people taking care of patients and the technology that makes it all happen. And their day-to-day work is all over the place. They're the person who connects a brand new MRI scanner so it can talk to the PACS. They control who gets to see which patient images. They keep an eye on the system to make sure it doesn't run out of space, and yeah, when an image fails to send at 2 in the morning, they're the one who gets the call to figure it out. So if we go back to our library analogy, the PACS administrator is the master librarian. They organize all the shelves, they manage all the library cards, they make sure the building is secure, and they help everyone find the exact book they need the moment they need it. They're the true custodians of the whole archive. Okay, so for all these different machines and computer systems to work together so smoothly, they all have to speak the same language. And in healthcare IT, there are 2 universal languages that are just absolutely critical to know about. The key here is to understand their different jobs. DICOM is the language for the images themselves. Think of it like a PDF, but for medical scans. It's a universal container that every single machine can understand. HL7, on the other hand, is the language of data. It's like a secure email that carries your patient info, the doctor's orders, and the final report. This standardization was a total game changer. Before this, you were pretty much locked into one company's equipment. Now, a hospital can buy the best scanner from one company and the best software from another, and they all just work together, seamlessly. Of course, like any complex piece of technology, things can and do go wrong. A reliable PACS isn't just about having good software. It's about constant, careful upkeep and really smart troubleshooting. So when an image doesn't show up, it's not time to panic. It's a logical process. The administrator starts with the absolute basics, just like you would with your Wi-Fi at home. Is it plugged in? Is the network even on? Then they move to the language. Are the DICOM settings all correct? And finally, they check the library itself. Is the server online? Does it have enough storage space? It's a step-by-step investigation. And really, it's all the proactive upkeep that prevents most problems from ever happening. We're talking a secure, dedicated network just for these images, really powerful servers that are always on, and this is the big one, regular automatic backups. Losing patient images would be an absolute catastrophe, so nightly copies are sent to off-site or cloud locations. This is the digital insurance policy that protects that priceless library. So, let's bring all these pieces together and zoom out for a second. Why did we go through all the trouble to build this complex digital library in the first place? Why does this all matter so much? Well, when you compare it to the old world of physical film, PACS is a complete revolution. The speed of access goes from taking hours or even days to just seconds. The reliability is way higher. No more lost films. And in the long run, the cost of managing digital files is just dramatically lower than printing, storing, and physically moving all that film around. It's not even close. So let's just quickly recap the big takeaways. PACS is that digital library for all medical images. It's what replaced that slow, expensive film. The administrator, our librarian, is that key human in the middle. The special languages, DICOM and HL7, make it all possible. And all of that behind-the-scenes work leads to one thing: better, faster, and safer care for patients. And that's really the bottom line. You may never see it or even hear its name mentioned during a hospital visit, but PACS is always there, working tirelessly in the background. It is the essential electronic backbone that supports pretty much every diagnosis that involves an image today. And that, of course, brings us to the future. With artificial intelligence that can now analyze images for early signs of disease, this incredible digital library is about to get a whole lot smarter. The next chapter for PACS is really just beginning. What's it going to look like when the library can not only store the books, but actually start to read them for us?